So in this question, we're asked to use de Moivre's theorem to prove the identity that cos of 3 of theta is equal to 4 cos root 3 over angle minus 3 cos over angle. So de Moivre's theorem says that if we have, say z is equal to or cos theta plus I sin over angle. So if we have z is equal to this, it just says that if z is raised to a power, it's equal to the modulus, say, squared, and then cos the angle will be double 2 by our angle plus I sin of 2 by our angle. So that's de Moivre's theorem. So if we have cos 3 of our angle, which we have in this question, so it would be or cos of our angle plus I sin of our angle. So if we have that all to be cubed, it's going to equal to so or all to be cubed by cos 3 plus I sin 3 over angle. So that's basically what de Moivre's theorem shows us. So we're asked to use de Moivre's theorem to prove this. We're asked to use de Moivre's theorem, so this is using de Moivre's theorem. We've shown that this cubed is equal to or cubed and then cos 3 by the angle plus I sin 3 by the angle. So our or's, we're having or squared on both sides, so the or cubed, will cancel, and then it's going to be cos plus I sin of the angle cubed is equal to cos 3 over angle plus I sin 3 over angle. So I'm going to have to multiply this out. So say if I have cos over angle plus I sin over angle multiplied by cos over angle by I sin over angle squared. That's the same as this. So I'm going to do the squared part first because I think it's easier if we square, multiply it by itself once first, and then we can multiply itself but again by the third time. So cos by cos will be, say if I'm going to get this bracket here, I'm going to do this out. So cos by cos will be cos squared over angle. Cos by I sin will be plus I cos over angle by sin over angle, and then this by cos will be plus I cos over angle by sin over angle, and then we'll have minus plus I squared sin squared over angle. So that's if we multiply this this bracket here multiplied out. So I'm just going to fix this up a little bit. So it's going to be cos squared over angle plus it's going to be 2 I cos over angle sin over angle plus, so it's going to be minus 1, I squared is minus 1, so it's going to be minus sin squared over angle. So this is the part, this is there when we multiply it by itself. So then we also have to multiply that again by cos squared plus I sin, say cos to the angle by sin plus I sin to the angle. So cos by this will be cos cubed and then over angle plus 2I cos squared and then sin the angle minus cos of the angle minus by sin squared of the angle. And then I'm going to just go on to the next line to do the sin part. So then it's going to be plus I cos squared over angle by sin over angle, and then it's going to be plus 2I squared cos over angle. Sorry, can you see that there? It's going to be plus 2I, so I'm just multiplying this by this, plus 2I squared cos over angle by sin squared over angle, and then it's going to be then we're multiplying this by this. It's going to be minus I sin cubed over angle. So I'm just going to tidy this up a bit. So we have cos squared over angle. So anything we can maybe cancel out. So we have, well, do we have any I squared? So I have to deal with that I squared. So we have cos. So I'm going to keep the things without the I together. So I have cos of the angle minus this minus cos of the angle sin squared of the angle. So I've dealt with this, I've dealt with this, and then we're going to have minus, this is going to be a minus 2 cos of the angle sin squared of the angle. So I've dealt with this, and then it's going to be plus 2i cos squared sin of the angle, and then it's going to be plus I cos of the angle squared plus sin of the angle squared minus I sin cube of the angle. So, but I was asked to show that cos 3 is equal to this. Now, the imaginary parts, so say this is our, there's no other kind of tidying up. Well, I can do a bit more tidying up on that, sorry. So I can make that look like, so cos cubed 3, so that's going to be minus 3 cos over angle sin squared over angle, and that's going to be plus 3i cos squared over angle sin over angle minus 1i sin cubed over angle. So this is cos 3 over angle plus sin. So I'm asked to equate, so but I'm asked for cos of this, but this is equal to this plus this. So if I let this equal the real part without the I, I'll have an equation. So cos 3 of the angle is equal to cos 3 minus 3 cos sin squared over angle. So now I'm after equating the real parts of what I'm after getting with the real part. So we're asked to prove the identity, but we're not asked to have any sins in our identity. But we know that cos from our log tables of an angle, cos squared of an angle plus sin squared of an angle is equal to 1. So sin squared of an angle is equal to 1 minus cos squared of that angle. So we can let that equal there. So cos 3 is equal to cos cubed over angle, minus 3 cos over angle 1 minus cos squared over angle. So now if we're going to do this out, it'll be cos cubed minus 3 cos over angle plus 3 cos cubed over angle. And now for just to add the cos cubes, it'll be 4 cos cubed over angle minus 3 cos over angle, and that is equal to cos by 3 over angle. So that is our answer. Thank you.